Hello everyone, I'd like to welcome you to this video titled Generating Equivalent Expressions. I would like for you to get out your math journal, your pencil, and also your Go Math book and turn to page 275. Now the goal for the video is for you to understand how you can identify and write equivalent expressions. Now some people may be thinking, what do you mean by expressions? Okay, so understand that an algebraic expression, that's what I'm referring to, is an expression that contains one or more variables and may also contain operation symbols such as addition or subtraction or multiplication or division. So when we're talking about generating equivalent expressions, that means we're going to look at one algebraic expression and see and figure out if it's equivalent to another one, or combining terms, we'll talk about that here in a little bit, to create an equivalent algebraic expression. So as we begin to look at this, there are a couple things that you need to understand. You need to understand properties of operations. Okay, so what this will do, this will allow you to understand how an expression or an algebraic expression could be ordered a different way and still be equivalent to another one. And there's also some things as far as multiplying numbers and the distributive property, a lot of different properties that will help you grasp the concept of why does one expression look different, but yet it means the same thing, or it's equivalent, okay, or equal. So understanding these properties is very important. And you can find these properties on page 277 in your Go Math book. So I do suggest you turn to 277 and take a look at these. So understanding commutative property of addition. Basically, the idea of that is you can change the order of numbers and you can add them in any order that you would like, and they'll still equal the same number. For example, 3 plus 4 equals 7, 4 plus 3 equals 7 as well. So we would say that 3 plus 4 and 4 plus 3 are equivalent to each other. Even though they are in a different order, they're equivalent. So understanding that is important. Also, commutative property of multiplication, same idea. When multiplying, changing the orders of the numbers does not change the product. And I've talked about this throughout math this year. So 2 times 4 equals 8, 4 times 2 equals 8. So even though they're ordered differently, 2 times 4 is equivalent to 4 times 2. So you can see commutative property, commutative property. The way I remember this is if I think about commutative, that sounds like community. So all of you live within this district's community, okay? So think about you can live in another house or you can move within the community and you're still a part of this community, okay? So you can go a lot of different places. You can change the order of houses and so on, but we're still in this community. Hopefully that helps you understand that you can change the order of addition and multiplication problems, but yet it's still the same answer. Now, the next properties that we're going to look at are the associative property. And I will say commutative property, there's not a commutative property of division or commutative property of subtraction because the order does matter with those types of operations. Okay, associative property of addition, associative property of multiplication. Okay, you can see these two go hand in hand. Property of addition, when adding more than two numbers, the grouping of the numbers does not change the sum. Okay, so for example, if I have 3 plus 4, if I add those two together and then add 5, that gives me 12. If I have 4 plus 5, that gives me 9, then add 3, that still gives me 12. So you can group the numbers however you would like, and that goes with both multiplication and addition. All right, now one that we're going to be looking at a lot throughout today's lesson is the distributive property. So multiplying a number by a sum or a difference is the same as multiplying each number in the sum or difference and then adding or subtracting. So for example, if I multiply 6 times 2, that gives me 12. 6 times 4, that gives me 24. 12 plus 24 gives me 36. okay? And then I could even do, first of all, 2 plus 4 gives me 6. 6 times 6 gives me 36. So these are examples of how the distributive property works. Whenever there's a number outside of a parentheses and there's not an operation, that signifies that you need to use the distributive property. So that means you're going to multiply everything within these parentheses here by 6. You're going to take 6 times 2 and then 6 times 4. With this one, 8 times 5, 8 times 3. Okay, so it's important to understand that. Identity property of addition. Adding 0 to a number does not change its value. I think we all understand that, but understanding the specific property that goes along with that is important. So in other words, the 9, when it's added to 0, it maintains its identity. It does not change at all because you're adding 0 to it. You're adding nothing to it. All right. And then identity property of multiplication. Any multiplying number by 1 does not change its value. So think about it again. The 7 does not lose its identity when you multiply it by the 1. Okay, so 1 times 7 equals 7. So understanding these properties, understanding that algebraic expressions, even though they may look different, they can still be equivalent to another algebraic expression. Okay, and understanding these properties will help you hopefully understand that. So let's take a look at some of these problems here, and these are on 278 in your Go Math book. So we have two algebraic expressions. Okay, understand algebraic expressions from the beginning. When we were taking a look at that definition, is an expression that contains one or more variables and also can contain operation symbols such as addition or subtraction and so on. So we have two algebraic expressions and we're trying to figure out if they're equivalent or not. So even though they look different, they could still be equivalent here. Okay, so I have 6x minus 8. We're going to see if this is equivalent to 6x minus 8. So what we do, we're doing the distributive property. Okay, so what we're doing is we're multiplying. Let me show you what this actually looks like. 2 times 3x and 2 times 5. That's what we're doing here. Okay, so 2 times 3x, whenever you're multiplying 2 times number in a variable there, and we'll get into what this is actually called. Okay, so the coefficient here, and I'll get to that definition here in a little bit. That variable comes along for the ride. It doesn't disappear or anything like that. So 2 times 3x, all I do is multiply 2 times 3. Simple enough, right? That gives me 6x. And then 2 times really -5 here. Okay, keeping that symbol there. 2 times -5 is going to give me -10. Or you could even just say that that subtraction sign stays there. So I have 6x minus 10, 6x minus 8. This would not be equivalent to each other here. Okay, not equivalent at all. Now the next one, let's take a look at number 7 here on in your Go Math book on page 278. Okay, so what we have 2 minus 2 plus 5x. And then we have the algebraic expression of 5x. So are these two equivalent? So first of all, 2 minus 2, that gives us 0. So we don't need to write 0 at all. And then we just have 5x remaining. Okay, there's nothing to combine there or anything. So we have 5x and 5x. So these two expressions are equivalent. Okay, so understand that with algebraic expressions, they can look different. Okay, but when you start breaking it down and start using the different properties, you can see how two expressions that may look different in the end actually are equivalent. Okay, so these two expressions here are equivalent. Now, what I would like you to do is go to page 279, and we're going to look at generating equivalent expressions. So, in other words, we're going to take a look at these long algebraic expressions, probably expressions that you've never really even seen before in your life, and they may look very scary, but we're going to break it down, take it step by step. And this idea of generating equivalent expressions will continue to help you as you move through algebra in the next couple years in middle school. Okay, so couple key things that we need to understand. Breaking down the parts of an algebraic expression. Again, this is on page 279. I do suggest you writing these in your math journal. That can be very helpful. Okay, so first of all, the terms. Okay, I'll talk about this a lot throughout today's video as we go through these next couple slides here. The parts of the expression that are separated by the plus or minus signs. Okay, so you could see 12 is its own term. 3y to the power of 2 is its own term. 4x is its own term. 2y to the power of 2 is its own term. And 4 is its own term. Okay, so understanding that is important. So those are all terms. So I'm going to talk about combining like terms. Okay, we'll get to that. Also, coefficients, numbers that are multiplied by at least one variable. So we talked about in previous lessons that whenever a constant or a number is next to a variable, there's not any operation sign or anything, it means it's being multiplied. So coefficients are numbers that are multiplied by at least one variable. So we see 3y to the power 2, 4x, 2y to the power 2. Okay, so those are coefficients. 12 and 4 are constants. Okay, but 3y to the power 2, 4x, 2y to the power 2 coefficients. Why? Because they are numbers that are multiplied by at least one variable. Now, like terms, that means there are terms with the same variables raised to the same powers as well. Okay, so understand that like terms, so we could see 3y to the power of 2, that's a like term to 2y to the power of 2. Now, if I had something like this, 3y, that would not be a like term because it has to have the same variable and it has to be raised to the same power. So 3y to the power 2, since it's raised to the power 2, that's a like term. Even if it was 3y to the power 3, still not a like term because it's not raised to the same power there. Okay, so understand that. So terms with the same variables raised to the same powers are like terms. So when an expression contains like terms, you can use properties to combine the like terms and write an equivalent expression. And the properties I'm talking about are the properties found on page 277. So now we are ready to start combining like terms. So let's take a look at this here. Okay, so what we have here, number 9, and this is right in your Go Math book on page 280. I'm going to do a couple problems with you first, and then we'll do a couple together. Okay, so number 9, we have, and I always like to rewrite these. I know you say, Dr. Mangan, you like to rewrite everything. That is exactly right. Okay, it just helps me kind of focus in on what we're doing here. So we have 8y minus 3y. So understand, whenever we are combining like terms, whenever we're generating equivalent expressions, we need to think about a couple things. We got to combine like terms. So this isn't too difficult here. So what I like to do is I like to create boxes. Okay, that helps me kind of figure out what terms are on their own and separate the different terms and so on. Okay, so I have 8y minus 3y. Okay, so basically I'm just combining these terms. Whenever you're doing this, think about, let's say y equals yellow crayons. Okay, so if I have 8 yellow crayons and I'm taking 3 yellow crayons away, I just have 5 yellow crayons here. Okay, so when I'm combining like terms or when I'm generating an equivalent expression, 8y minus 3y is equivalent to 5y. after I combine the terms. Again, it's just another way of writing it out. Okay, so understand that. Now, let's take a look at number 10. So this one is not too difficult, but when you get into some of these, it can be a little tricky here. Okay, so I'm going to erase this here. Let's get this out of the way, and let's take a look at number 10. So we have 6x to the power 2 plus 4. Okay, now we have our parentheses. Remember, whenever a number is next to a parentheses without any operation sign, it means you're going to use the distributive property, and you are going to multiply 4 times 2x and then 4 times -1. Okay, so what I'm going to do, I'm going to use the distributive property here. So I'm going to multiply 4 times, I think I said 2x, x to the power of 2. So 4 times x to the power 2. And whenever there's a variable without a number in front of it, it's understood that the number in front of it is 1. Okay, so what I'm doing is taking 4 times x to the power 2, and that's going to give me 4x to the power of 2. And then I have 4 times 1. It's going to give me 4. We have our subtraction sign there. So that's 4. And now what I have here is I have 6x to the power of 2. And I'm going to keep my positive sign there, my plus sign. Okay, now I have used the distributive property. Now it's time to box all my terms in. Okay, so I'm going to box all my terms in here. I'm going to keep the positive and negative signs here. All right, so now what I have here, whenever I'm combining like terms, remember like terms, that means there's terms with the same variables, if they have variables, raised to the same powers. Okay, so I have x to the power of 2, x to the power of 2 here. So that means 4x to the power of 2, I'm sorry, 6x to the power of 2 and 4x to the power of 2 are like terms. So that means I combine them. How do I combine them? Very simple. Just add the numbers in front, okay? Or if it was a negative one, I have to subtract these two. Okay, so 6 plus 4 gives me 10. The variables and so on, and the exponents come along for the ride. So I'm finished with these. Okay, put check marks above them, you can cross them out. Now I just have -4, and then I just write -4 here. All right, because there was nothing to combine -4. If there was another whole number, I could, but there's not. So an equivalent expression of 6x to the power of 2 plus 4 times x to the power of 2 minus 1, an equivalent expression is 10x minus 4. That's an equivalent algebraic expression. And we use the distributive property to break that problem down. Now let's take a look at another one here. Let's take a look at number 11, and I would like for you to do number 11 with me in your math journal. So again, writing these out step by step is very important. So now for number 11, we're going to write these out. 4a to the power of 5 minus 2a to the power of 5 plus 4b plus b. You could also look at this as positive 4a to the power of 5, negative 2a to the power of 5, positive 4b, positive b when you're combining the terms. So after I've written this all out, I'm going to box all my numbers in. Okay, and I'm going to do this. I'm going to separate all my terms. I'm going to make sure I have that positive or negative sign or that addition or subtraction sign in front. Okay. Now what I need to do is I need to combine like terms. Remember, like terms have the same variables and also they're raised to the same powers. So what I have here, I have a to the power of 5. So obviously these two are like terms. Okay, so I have 4a to the power 5, I have negative 2a to the power 5. So combining those terms, I have 2a to the power 5. So I've used those. Now I have positive 4b and b. So understand, whenever there's a variable all by itself, it's understood that there's a 1 in front of it. Okay, so if I'm combining these two terms, remember, same variable, they're raised to the same power, which are not raised to any power. Okay, so for this one, 4b plus b is going to give me 5b. So the equivalent expression to 4a to the power 5 minus 2a to the power 5 plus 4b plus b is 2a to the power 5 plus b. So again, very, very important to understand that like terms, what that really represents, they're terms with the same variables raised to the same powers. Understand it's very important that you cannot just combine terms if they're not raised if they don't have the same variable or raised to the same power. Let's take a look at number 12. We have, first of all, we're going to write it out. I'm going to erase this. So we have 8m plus 14 minus 12 plus 4n. Okay, we've written everything out. Now it's time to box everything in. This helps us separate our terms so we can see it a lot easier here. Okay, so first thing we do is we take a look at 8m. Is there any like term with 8m? There is not. Even though we have another coefficient here, it's not the same variable or raised to the same power. So what we're going to do, we're just going to write 8m under here, okay, because there's nothing to combine it with. So we're finished with that. Now we have positive 14, negative 12. Whole numbers, yes, you can combine them. Okay, so basically we're taking 14 minus 12. That's going to give us positive 2. So we're finished with these two. And now we have lonely 4n here all by itself. There's nothing to combine it with, so we will just write it underneath here. So we have 8m plus 2 plus 4n is the equivalent expression to 8m plus 14 minus 12 plus 4n. So that's how you use the different properties and understand that even though the expressions look different, they are still equivalent. So this concludes a video on generating equivalent expressions. If you have any questions about this concept, please come and see me.